Thank you, everybody, for joining us today. It's a pleasure to be here and also a great honor to present a little, let me say, short view of the state-of-art report, which is the Subtask A on the Annex 88. As Professor Takao mentioned, I'm a professor at the Mechanical Engineering Department at the University of São Paulo, Brazil. And with Professor Takao and Professor Luai, we coordinate and editing this report that I'm going to show a little bit now. As Professor Takao mentioned, we divided the report in 4 chapters. The chapter 1 will be testing methodologies and performance rate standards for heat pumps systems, where we can see a little bit of what is done by in a review of the main testing methodology that we find in the literature and also with the support of our team. And the chapter 2, we have the monitoring and also the methods and database for actual energy efficiency of heat pumps. Chapter 3 will be energy use calculation methods for heat pump systems, and chapter 4, design guidelines for heat pump systems and buildings. The idea here is to give an overview of everything of each one of these topics and try to make as thorough as possible for the reader to have a very good idea what's happening and on each one of these topics, and try to understand what's the challenges, what we already accomplished with that, and try to move on and try to make it anything related to heat pumps more efficient and more accurate in the sense of predicting his behavior or in the sense of energy and operations. So in chapter 1, you will see the testing methodologies and performance rating standards for heat pump systems. We divided in 2 categories, A and B. Category A is the steady state testing, compressor speed fixed. So the idea here is to have some ideas what do we have for testing methodologies on that kind of type of operation. And category B, you have load-based testing, when we account for real-world performance. Because one thing is to test it in, let's say, standard and very fixed conditions. The other thing is how this heat pump will work in a real-world environment. So the idea is to figure out that, and then we have here today Professor Nicolo Gianetti, who will go a little bit through all that. Then in chapter 2, monitoring methods for heat pumps. The idea here is to understand first how is the impact of partial load ratios and the current testing standards for that, and also monitoring methods for air and hydronic systems. The idea here is to look at all these 2 types of systems and also understand how we can monitor that to evaluate its performance, and also understand how we can predict that. So we're going to go through the air conditioners, indoor and outdoor temperature enthalpy difference, for instance, one method, the refrigerant enthalpy method as well for air systems. For hydronic systems, we're going to show a little bit of the water side methods and some standards that work with that. And we're going to have today Professor Baolong looking a little bit more in detail about these methods. Chapter 3 is the energy use calculation method. And the idea here is to, as we have a lot of the oil crisis in 1970, energy policies evolved from that, trying to figure out the ways to have more reliable methods for calculating heat pump energy consumption. So we have a lot of challenges on that. The first one will be accuracy and comprehensiveness of the energy calculation methods. Some challenges we're going to face on the data input for these energy calculations. We have a lot of parameters for that, and how accurate and how detailed is that will be a difference between a good quality and a bad quality energy calculation. And also how the operating conditions impact on the energy calculations for these kind of systems, on the partial load ratio, outdoor temperature, and so forth. The team for this chapter review some methods of energy calculations, 8 of them that are related to standards, European standards, softwares, and other issues related to the energy calculations. And we have, with one of the things that pops out from our evaluation, that there was a variability in heat pump calculation methodologies across countries. So the idea here is that to understand if there is something that it's local, so we can understand what's the needs for that on each country, and perhaps understand how to figure out how to do this energy calculation methods in a proper and ground way. Finally, the chapter 4, design guidelines for heat pumps. The team for that chapter made a review of the installation design guidelines for such systems, and they focus also in hydronic and air-to-air systems, where we're looking for several standards for designers. Some of them are shown here, and also in the second day that we're going to have our second webinar, chapter 3 and chapter 4 will be showing more detail for you to understand what we accomplish on that review and report. As Professor Takao also mentioned, nothing of this wouldn't be possible without the cooperation of a very hard work and very talented team that we have here. I have the pleasure to work with you as editor, with Professor Luai and Professor Takao Sawashi, and all the people from our team. And I also want to thank for the reviewers that provide us inputs for improve our text and everybody who worked that so hard. So thank you very much for that.